Hey everyone, welcome to the Latent Space Podcast. This is Alessio, founder of Kernel Labs, and I'm joined by Swix from Cognition. First time I introduce you at the new role.
We haven't figured out the official title yet, but yes, we're recording this the day after we announced the Series C, and it's very good. Alessio is also part of the Cognition family now. We all had a fun party at the house, but today's not about us. Today we're talking about research, SmolLM, model training, all that stuff with Elie from HuggingFace. Welcome.
Yeah, thanks a lot for the invitation. I'm very glad to be here, and congrats again for this new job.
So you obviously, I think I actually first reached out about SmolLM. I think that honestly, SmolLM 3, one of the single best open source AI research papers I've read. I think probably in like a year, maybe 2 years. I don't know. Yeah, it's very, very good. But I think maybe let's just get a high level, who are you? What do you do at HuggingFace? All that stuff.
Yeah. So I think most of the people know HuggingFace for the hub or the transformer library. And we also have this research team where we basically try to explore in the open all the science subjects. It could be, we have a team working on data, obviously, with the FineWeb, the recently released FinePDF. And we also have this team working on pretraining and training models such as SmolLM. And we are basically a very small team of 30 people in average. And we try to do some cool stuff that the community will love and will reuse to build on top of it and to contribute to the open science, basically.
Yeah. While you mentioned the FinePDF, why don't you plug FinePDF a little bit? I think a lot of people know FineWeb, but what's good about FinePDF?
Yeah, I think I have some.
Oh, okay. It's already in your slides. Okay.
Yeah, it's already somewhere. I think it's here.
Oh wow, and that's very recent. Okay.
Yeah, that's. I updated it today. So it's basically cool because I think we have a lot of high quality dataset, and the field of dataset people have been building some awesome stuff. NVIDIA Datology, they didn't release it yet, but this is pretty cool as well. And one thing that was missing, AI2 also, of course. And one thing that was missing is a new source of data, and PDF was greatly underexplored. So that's what our team did, and you can see the performance is pretty impressive. If you take this curve, when mixed with other web datasets, not PDF one, it basically have a very, very, very good performance compared to this Nemotrans SCV2, which is a very recent release from NVIDIA. So it's pretty cool. And there is all the pipeline. So I didn't work on this. It's INEC who mainly did a lot of great job on this. But there is all this pipeline where he benchmark a lot of PDF extractor. And we are cooking a blog post where we'll explain basically all the step of this pipeline.
Yeah. What is this refetch from internet step? What is that? Is that a very common thing?
Yeah, I think this is the way it works is that, yeah, so sometimes I think the PDF from Common Crawl are not really well extracted, basically. So I think what he did here is that he refetch it from internet to maybe have a better version of it if it's more recent or I don't know.
Yeah.
So,
okay.
Yeah. And there's a lot of it.
Yeah. So obviously you get data sets. I actually previously talked with Hugo Laurenson of the Vision team, and Idefix and Obelix was really cool for Vision as well. You are on the training side. What is this unified view of model training?
Yeah, so I didn't say that, but my job at HuggingFace is being the guy that's keep in touch with what's the pre-training innovation are. And my view of model training is basically you have those different objectives that are somewhat orthogonal to each other, and you can explore in parallel. The first one is is basically maximize the relevance of the raw information, meaning maximize the quality and the diversity of the data. This is probably the most important one. It's not really the one that people are often the most excited about, but I think it's pretty well known now that like there is this garbage in, garbage out thing that it's basically super important to have very good data and like a very good diversity. But you can also optimize for other things, and this is quite orthogonal to the dataset. So you need to have a team that build a very good dataset. You also need to have a team that do research on model architecture to basically have construct the best model possible under certain constraints. And the constraints are like the efficiency. So you want a model that will be good at inference, that will like fit on a certain number of GPU, that will have a certain like KV cache consumption and things like that. So this is like the model architecture part. And when you are fix like this dataset and model arch, you can also maximize the information you get from the data. So at each step, you basically want to maximize like how much you extract from the data. One way to do that is to do this locked distillation. There is other way to do that. It's also related to the architecture part, but there is this multi-token prediction, which is very good, for example, for coding. And basically there is also other steps such as like maximize the quality of the gradient you get. Meaning like when you do your update step, you need to maximize this quality of the updates. So this is like different optimizer, thing that will approximate the Hessian matrix, for example, or just like project into better space for learning. And when you have all of this, you want to have basically the right hyperparameters to make sure that your training is not exploding because it happens quite a lot, especially when you scale at just like your gradient or your activation are doing like completely diverging. There is all this field where you want it to be stable. You want to understand how to scale from a smaller model to a larger one, and do this thing called feature learning, where basically you are at each step learning as much as possible from this gradient. So this is kind of my view of model training. There is of course some connection between all of them, but
and for these 5 steps, how do you think about which ones have the highest variability? I feel like some of them, there's kind of like a meta of this is how you get the best results. What are like the parts that are like still very not figured out, where like you feel like the most interesting research is being done?
So I think dataset is like the data is like, it's a bit unexplored because I think people don't find it very interesting. I mean, for a bit of time, like people were a bit under exploring like the dataset, especially since it's super important. But we've seen like recent paper and recent trend to build better and better data set. And so I'm confident that like, hopefully people in the open will somewhat catch up with like the big models. The rest of it, I think the model architecture, with like the Qwen, DeepSeek, Kimi architecture, we're already at a point where this is already not optimal, but this is like pretty advanced. And there is all this thing where basically you want to maximize, like to do some new optimizer and to really, have some good stability and scaling feature. This is a bit underexplored, and especially like since Qwen and DeepSeek paper doesn't really detail how they do the stuff. I mean, we've left with very few model provider, even in the open, that talk about all of this. And for example, a good way to view that is that DeepSeek V3 is still using the same Adam parameter than Llama 2. I mean, there is something wrong with it. I don't know if it's just me, but I feel that like the hyperparameters for Llama 2 AB, for example, shouldn't be the optimal one for this mega DeepSeek model with a lot of parameter.
Yeah. I think like a lot of it's almost weird. Like I wonder if we've hit the peak big model craze because now do you expect 10 trillion model releases, 100 trillion model releases? Probably not. I think we might have peaked at 2.
I mean, I'm always curious to know, like, Claude Opus, like GPT-5, like, what's the scale of those very big models? I'm not sure it's like that crazy compared to the Kimi one or Qwen that will probably release soon.
Both are 1 trillion models. All I will say is I have no insider information, but I have a lot of rumors thrown at me, and it is in the range of like single digit trillions. So cool. I mean, and then the other thing, we probably won't spend that much time on Optimizer, but I think like Optimizer is actually like one of the low-key more interesting trends this year as everyone moving to Muon. I don't know if you have a strong view on this. Like basically like all of these 5, I don't know where you want to spend the most time.
I really like all the Optimizer parts, but that's like more like a personal, I mean, I will not probably talk about this a lot, but that's one of the thing that I find cool because it's very recent basically. And it's like using, it's very recently that people start using something different than Adam. We know, for example, that like Google is using. We don't know, but like on like old paper, Google are using like Ada Factor. But recently, before this Kimi K2, everyone was using Adam. W. And recently there is the GLM paper. There is this Kimi K2, of course, that is trying to do some new stuff with Optimizer, and I find it pretty cool because it's like very deeply influenced the learning process of the model. So this is actually quite a big of a change, I think.
Can you give an intuition on what's going on? Like, I think the basic insight of Adam W was mostly like momentum, right? Momentum matters. You trade off, you use more memory and like, but in exchange, you get much better learning. Like, okay, fine. What is the core insight that everyone's sort of like exploring?
I think so I actually have some stuff about it somewhere. Somewhere along.
Somewhere.
Yeah.
I love it. This is like just like your notes of all the papers.
Yeah, this is exactly my notes. It's I didn't publish them, to be honest. So
it's great.
And this is like the Muon algorithm. So which is very simple, to be honest. And like the key part is this like Newton-Schultz method, which is basically taking this matrix and making it better in a sense that it will be somewhat orthonormal to be precise, I think. And this will have the property of like basically spreading the learning in more dimension than with this Adam optimizer. And I think this is why it's what they say. Yeah, I think. Yeah, it's more stable, and also it encourages more to learn and explore new things. And this is pretty cool. And they did this Muon clip optimizer, which is pretty cool. And actually, it's quite simple. They just track this quantity, which is the max logit per head. And if this quantity is too large, they are basically saying, okay, that's not good. I rescale after the backward my parameters by dissonance. To make sure that they scale down and they don't explode anymore. And this is actually, it only have an impact in the early step, and after it stabilizes and basically it doesn't have any impact. At this point, you can deactivate the QK clip and this will just work as well. So this is pretty cool. And they find it by just looking at their log, and they see this crazy maximal attention logits. And they are like, okay, there is something wrong and I need to contain those attention logits. And the method they choose is this QK clip stuff. There is actually different stuff to do that. There is like this IDON Z loss, there is the QK norm, there's a lot of stuff that kind of want to patch the same thing, but this one is quite elegant, to be honest, because it's very simple.
Yeah. Cool. Do you, just a side follow-up, did you actually follow the sort of schedule-free optimizer stuff from last year with Aaron DeFazio? Anything came out of that?
I don't have a strong opinion. I tried it like a few days after it was released because we were writing a paper about the WSD schedule. And so this was kind of an alternative to it. And it didn't perform as well as like a simple Adam W. And it was more sensible to the beta 1 and beta 2. But I think like with this kind of stuff, you really need to have this knowledge on how to optimize those hyperparameters for each optimizer to really get the best performance of each one. And so I don't want to say something bad about it, because basically at 19%, there is a 90% chance that it's just me that used the wrong hyperparameters. But yeah.
Yeah, you're holding it wrong. Cool. I mean, I'm happy to zoom out. Sorry, I feel like I sort of zoomed in on optimizers just because you're one of the few people that we have on the podcast that can talk about it.
Yeah, I mean, and there is a lot more to that. There is Muon, but there is also Shampoo. So there is a bunch of series of optimizers that must try. But
if you do, you want to keep going? Yeah, I was.
I'm not sure I have the slide for Shampoo and soap. I like this slide. This is from my previous set of slides. Basically, I was like looking at what the lab are like using, and I basically saw that every open model we are using Adam.
Yeah.
It was kind of crazy. And
it's pretty validated at this point.
Yeah. And since then, there is this new Muon trend. There is this recent paper talking about the different optimizer. And
this is this week.
Yeah, this is this week.
Wow, these slides are super live. Oh shit.
Yeah.
Okay.
Yeah, this is this week, and this is basically saying that. So there was a lot of papers that claim some text speed up and things like that. And what they find is that this speed up is greatly exaggerated, and mostly because often people like undertune the Adam W baseline. And this is like something which is pretty there is always this problem where people are doing new architecture. For example, they are under like the baseline of the transformer is often under optimized. And so they basically say that when you increase the model size, the speed up is decreasing. But to be honest, even the author, I think, say that at this point, they didn't really optimize the hyperparameters. They just like do some, do some extrapolation, and like extrapolation can be a bit tricky. So this, maybe we can forget this one, but I think the speed up between 1.2 and 1.3 is pretty fair. And there is a lot of insights, such as like, if you don't do weight decay, you can get, those kind of curve. And if you, for example, take a look at like, step, 10,000, you can conclude that, the one with, weight decay equals 0 is the best. But in fact, at the end, it's not at all. So early curve can be a lot, like, can mislead a lot the interpretation. So it's, yeah. And also, like, you see here, if you don't tune enough your hyperparameters, for example, this is the true value they take for soap. And in one case, it's very bad. It even has like this spike, which is not great at this scale. And in the other scale, it's like beating the other optimizer. So yeah, it's pretty complicated to do all of that, but yeah.
Is there any value in the early curve? Like, even if it's like, not predictive of like the whole training, like seeing kind of like a faster slope in the beginning.
Yeah. So what I look, when I look at the early curve is mostly the spike. If there is some spike early on, it's never a good sign for the rest of your training. There is some, for example, if you compare different data sets, the early curve can give some information. It also depends on the schedule the long life schedule you are doing. We often use this WSD schedule, which means that basically you do this, like, as ergo, there is this stable phase. And why it's great is because you can basically decay, whenever you want. And so you do one run, one big run with, for example, a fixed LR, and then you decay, at different points, and then you can get this performance without doing like a different cosine schedule for all of them. So yeah, but overall, it's like, especially when doing optimizer ablation, you never want to look at early curve, and you want to like wait for the long rate to have fully decay and like the annealing to be to 0 or whatever value.
Wow, this actually is a really good paper. I like. There's a lot of insights.
Yeah, it's a great one. And the people who are doing it is like the Mine project at Stanford. They are really great, and they are doing some amazing open source stuff. So I really encourage people to check out what they do.
Awesome.
Yeah.
Okay. Anything else on the optimizer world that's going on? It's like interesting to you.
Yeah, there is this plot from the essential AI paper about Muon. And the idea of this plot is basically saying that you can use MuP you can use some technique to do hyperparameter sweep, and it's working with Muon, for instance. And there is this idea where so in this paper, they only did 1D hyperparameter sweep. So they fixed everything and they just changed the learning rate, for example. But for instance, there is some connection between the learning rate and the weight decay, or learning rate and batch size. But you always want to sweep together some of the hyperparameters, and this is what they do here. For example, they sweep both the learning rates and the weight decay together to find the optimal one for their training. So
yeah,
man, I think that's it for optimizer. Yeah,
I just realized this is a 4-dimensional chart.
No, 3-dimensional one.
It's 3, but then
there is also
this
one. Yeah,
that's the 4th dimension. Yes, correct.
Yeah.
Very interesting.
Yeah. What else comes to mind for you? I think we're kind of on the model consumers side. And so there's some of these things that get to the engineer side and we think are really interesting.
Yeah. Like sparsity matters to us, efficiency, speed.
I think the MOE is definitely something that is interesting to understand. And it's definitely interesting to understand how powerful it is. So for instance, the first graph are basically saying that you get better performance for the same number of flops. But there is this problem, and it's basically that, for example, here you get a 3x performance boost. But here if you look at the training times, you only get a 2x performance boost. And this is mainly because MOE are faster to train, but this is depending a lot on your code base. And there is actually some very small detail that can completely make your MOE very bad. I think one is this one. Is this is from Qwen, and they are basically saying that. So I don't know if I need to explain, but the load balancing is basically saying you have your different experts and you want all of the experts to get approximately the same number of tokens at each batch or at the end, because if you only have 2 experts that activate every time, it basically the other sparse will basically be useless. So one of the very important parts is this load balancing. And what they find in Qwen, so there is different way to do load balancing. I can talk about this later, but what they find is basically you need to compute those 2 statistics, which is at each step you look at how many tokens actually selected by each expert, and you look at the probability that is affected by the router, basically. And when you compute this statistic, you are doing that at the micro batch size level. So this means that, for instance, when you do training on multiple GPUs, let's say you just replicate the model on all the GPUs, you have this global batch. So it means that for example, you give 100 documents to your model. And if you have 5 GPU, you give 20 to each of them, because you want to parallelize this process. And then after you gather all the results together and you do the backward pass. And the fact that there is also the statistic is computed at the mini batch size is pretty important for the model. I think the most important part is this one. So basically, this is saying that the model is not really activated for code. There is no expert that are specifically activated for code. Same for math, same for literature. So this is all of this is the local batch. And if you do it at the global batch, so meaning that you give at each step you give enough token basically so that the statistic is meaningful. you get this very good and like this is basically a sign of good health for the MOE to have all those activated, like specific activation for each domain. And they find that, for example, in the Megatron LM code base, this wasn't the case. This was done as the local batch testing. So it basically means that everyone that is using Megatron at the time of the paper, I mean, it wasn't even a paper, it was just a blog. But they had this, they were in this regime basically, where the MOE were not like very specialized. And this is super important for end usage because, you want to have like specialized experts so that they really learn something different from each other. Even after, for example, you can do some pruning. And if you want to model only on code, for example, you can just prune out some of the English literature experts and just keep the ones that are activated for code. And then you can initialize your MOE with those and like bootstrap them. So there is like a endless possibility here. And yeah. So this is like a very small detail and it does have like a huge impact. Pretty crazy.
You mentioned is something that, you know, personally, I never trained a model. How easy is it to divide these skills? So when you say, you know, literature, math, and code, what can you maybe run people through the process of like, how do you kind of like funnel these things in different experts? And then is it just as easy as you said to like, I'll just delete the literature part, or is there some sort of like codependence between them?
Yeah, there is some codependence, definitely. So there is other way to basically limit this codependence, but there is definitely some codependence. And when you do pruning, I don't know if people are doing that. I think that's interesting to explore. But like at least in the open, people are not really like pruning, for example, the English literature. That was just some research idea that could be code in the future. But the specialization is actually done in the router layer of your MOE. And this is pretty important basically because this is like the step where you will learn, like each token will learn to which expert to go depending on like the meaning of each expert. And you can even have some fancy stuff. So this is like, I think it's from 2 weeks ago. This Longcat Flash from the DoorDash of China paper that released the company that basically released like a state-of-the-art model, which is pretty crazy.
This is the most recent presentation I've ever seen.
Yeah.
This is all like happening in the last 2 weeks.
So yeah, I mean, I'm trying to stay in touch with what's happening. And they have this zero communication expert, which I find pretty cool. I think it's the first time I see it in like a big model. I mean, I'm pretty sure it's the first time. And like it allowed the model to basically say this token doesn't like this token is like for example very easy to predict, so I should not have like allocate a lot of flops to it. But this token, which is for example for to answer a MMLU question, is very hard, so I will activate more of the real experts. But those are like just residual connection basically. And it's the first time I see that. I mean, it's great, but I mean, they have a very strong team because my guess is that it's pretty hard to like balance it, and to make the training stable. And they also have this change also, which is, I mean, I'm not sure I understand why they do that. I think I understand, but it's pretty novel as well. It's basically replacing the shared expert with some double attention layer. Yeah, it's pretty crazy. And there is a lot of questions for MOE. Basically, do you want to have shared expert or not? GPT-OSS, Qwen 3 doesn't have shared expert, but like the Qwen 3 next, which is like release like I mean, they didn't release it yet, but they submit the PR to Transformer.
This is literally last night.
This is not last night. This is like 4 hours ago, I think.
Oh my!
But
oh my god!
But yeah. And they basically have shared expert this time. So this is interesting. I think shared experts are pretty important too. So they basically act like as like the knowledge that you don't want, like you want your expert to be very specialized and you want the shared expert to be just like the basic stuff and things like that. That's the intuition behind it. And I think DeepSeek is using that as well.
What do you see as like the even more granular MOE future? You know, I think it makes sense for people. It's like, hey, it's like code and math and literature. Do you see a future in which the MOE model is like, front end expert, like, if it's like a TypeScript code base, is like, oh, this expert, like the routes is an expert at, the component is an expert at the test writing. Like, is that something that makes sense? Are we bottlenecked by the data, or what are people doing there?
So my intuition, I don't really know, but my intuition is that, for instance, between math and, I don't know, all the history, like the Greek history, for instance, no, not really the Greek because it's related to math, but let's say code and Greek history, there is not a lot in common, except just the fact that the language is the same. But between, like, for example, I don't know, TypeScript and JavaScript or Python and I don't know what language, there is more similarity. So I'm not sure if it's like there is maybe more transfer learning, meaning that a model trained on like Python and JavaScript will benefit from the JavaScript data as well. I'm not sure it's the case for example for Python Greek history.
Yeah, I think like the question of semantic experts is always something that people are wanting to have intuitively, but the machine learning terms, it never works out that way. I actually feel like people are moving towards more semantic experts. It's like somewhat started by Apple, because they want like sort of downloadable lores and stuff. I remember, Gemini 3N also had this, where it's like downloadable, offloadable weights. This is like a really severe
Gemma 3N.
Gemma,
yeah.
I see some moves. I don't know how serious this thing is, but like if you're going to the point of having a router for different models, like semantic experts at some point make sense.
Yeah, and what I like is I think there is this recent trend where OpenAI basically saying that they want like a router for a user to be to have like something. And I think it's great for
You might as well.
And this is kind of the same principle, but baked inside the model. So I find it pretty cool because it's basically saying, if the request that I have is easy, I will just not allocate, I will basically do inference with fewer experts, which is the equivalent of GPT-5 mini, for example. And if I have like a very strong question, I will basically activate all the experts. But they do it at a scale where it's basically varying between, I think it's like there is the variance is like 4 billion parameters, so it's not a lot. And I think GPT-5 mini and the big one don't have the same number of parameters at all. But this is cool to see those behavior cooked and baked into the model.
Yeah, amazing.
Yeah, I don't know. I can talk about MOE or other stuff. What do you want?
Guide it however you like. I think the other trend, what definitely was more granular, experts. It was going up to like 120 or something. I don't know if you have a chart here. Okay, it looks like some kind of efficiency.
Yeah,
go ahead.
Exactly. And this is like basic. I think so. This is like the active number of parameter here and the total number of parameter here.
Yeah.
So this is basically the MOE sparsity. And you see that, so those are like the kind of old model and they are like not really great in terms of sparsity. But if you look at the new one, they are even like the scheme K2 is pretty insane as well. I think we keep like the new Qwen they will release will be somewhere here, I think. I'm not wrong. If I read it well. So this will be Qwen
Max or Qwen Next.
And 3 Qwen Next. Yeah. I think this would be...
I would say, from what I've heard, Gemini Flash is also pretty strong around this.
Yeah, I mean, MOE, like, Google is kind of pioneer in this MOE field. I think MOE is from them Chaser as well, so
of course.
Everything is from him, so...
Everything is from him. I think, like, what was the difficulty for being this sparse before? Right? Like, is it just stability of training?
So this is definitely one thing. Also, I think like training code base, you really need to have an optimized infrastructure and optimized training code base to have this good sparsity. Because the way it works is that you basically are distributing the expert on different GPUs, and in the MOE layer, they basically need to sync before, because like the router is dispatching the weight to the token to the different experts. And basically, the more granular it is, the more this step can be costly in terms of communication. So this is one of the reasons why it wasn't really good. For example, we are training a MOE currently at HuggingFace. We'll train soon. We start the training soon. Yeah. We tried with Megatron, and we benchmark, like, for example, the Mistral architecture with the Qwen 3, this one. And at the start, before any optimization, like the Mistral one was very fast and have very good throughput. And the Qwen 3 was very slow to train. But we basically, with the new kernel, all this new stuff, it became feasible to train. And there is also this sparsity. It can basically make the training sometimes a bit less stable. And it's kind of a bit thing. I don't know if, for example, this Olmoe paper, they basically benchmark this number of experts, so 64 and 32, and they didn't find like much difference between them. But if you look at like a more recent sparsity scaling law, you find that there is this is basically the different sparsity coefficients, and you find that there is actually quite some improvement. And of course, there is like diminishing return, but you can increase the sparsity quite well. And it's very good at inference. I think that's the main arguments, that inference is very good, because you can have very fast inference because there is only a very small subset of the parameter that is activated. Yeah,
I think one of those things that's kind of interesting as a pattern is like MOEs as a production artifact, but not as a training target. So the training target, you just have the dense model, and then you distill to the MOE model. Yeah, I think I think this is the pattern for every frontier lab now, and I'm just not sure. Obviously everyone's why do you just train the MOE directly? It's because of stuff like this.
Yeah. I think they also train MOE from the start, but maybe less sparse, They basically do some more sparsity for the production model than for the one that is used to distill from. Actually, distillation is like quite a big thing that people in the open are not really doing yet, I think. But yeah. I think that's it for MOE.
Nice check. I think that the other thing, especially you mentioned the GPT-5 router, is this difference, because like MOEs have routers, then we're putting a router on top of another router. Like, it's ridiculous, right? Like, okay, what is the future of routers, right? Like, is there a fat router that is basically its own LLM? What does that look like? If you just extrapolate, like what does it look like in the future?
Like the feature of the router?
If we're going to the point of like putting a router on top of a router, isn't that the same job?
Yeah, and I'm actually, I don't have it in here yet, but let me screenshot something quickly from another paper. But if I go back here, there is this NSA, which is like the new DeepSeek attention, and it's basically a router inside attention. So you can see it as like a router inside attention, basically. Because, so there is this compression part, there is this sliding window attention part, so let's say. And there is this part where you are basically selecting which attention block is interesting for the specific token. So you are routing the attention of the token to some specific block of the previous one. So you have also some routing inside attention happening with those new sparse architecture. There is also mini CPM that have a very similar attention mechanism. But I think it's interesting because basically, like the more router you have, the more parameter efficient your model is. I think that's the intuition here, especially at inference. because you only activate a subset of it. And that's like the same logic for the model router, basically, because you are selecting the model with like fewer activated flops, for example, GPT-5 mini, compared to the big one. For MOE, you are basically saying, I'm only selecting fewer token, or I'm only selecting a subset of it. And you also have this same logic into attention external.
Yeah.
But yeah, it's pretty cool. Yeah, I mean,
can we maybe talk about what comes out of the training? I think this is like I don't know if there's any other part that maybe you think people don't cover enough, or like
definitely dataset. There's a big chunk there that we haven't covered, but yeah, up to you.
Yeah,
I think I guess like in and out. So this is the part that expert ML engineers like you do, and then there's maybe the two things that people who consume the models can do. One, they can build data sets, even if they don't know how to use it, because then they can go to some fine-tuning platform or training platform. And then there's the other side of post-training. So yeah, maybe let's start on the data set side.
Yeah, I mean, I think to answer also on the question, I think like the goal of like ML researcher is basically to cook the best model possible so that the user don't have to do much with it.
Out of the box, zero shot.
Yeah, that's I think pretty cool. And obviously a big part of it is like the data set. There is this recent paper, like the Beyond Web from the Dataology.
Yeah, we just had the Datalogy episode, I think, last week.
Yeah, I saw this, but it's pretty cool. Yeah.
So this is super recent again. I've not used to talks being this recent.
Yeah. Yeah. So, I mean, I've read it. I mean, I've read it fully, but I didn't spend that much time on it. But if I had to recap a bit the paper, the interesting plot are this one. And so this is like, I think the interesting one is that you basically want to rephrase. So this is about rephrasing. So basically so when you, like, there is the web data that is shit, to be honest. Like, there is a lot of very bad content in it. And there is one approach, and what we do in FineWeb-Edu, for example, that is basically filtering some educational content or some subset of the internet, which is often higher quality. And the question is like, what do you do with the lower quality data? I think that's how I see it. That's not exactly what they say in the paper. That's more my thought. But I think an interesting result is this graph. And basically, this is like the curve between low quality web and high quality web. So this is the web, basically. And if you only rephrase the low quality parts, you get this curve, the light blue one, which is kind of close to the one where you also rephrase. I know it's not that, but it's like, it gives you a big boost. And I think, I'm not sure if they do the ablation here, but I'm not. Yeah. Okay. So that's what they do. They also try to rephrase like in the high quality subsets, and they also repeat the dataset they rephrase on. And there is only a small difference. The new cool thing, it's because of the repeat. I'm not even sure it's because of that, to be honest. And the thing that you need to understand from it is like, it's very good to rephrase the low quality data, to have like just better benchmark and better performance. And rephrasing is a bit tricky to do. I think a lot of it is making basically the right prompt. And one of the good prompt, I mean, the good style that the model like, especially because the benchmark are constructed this way, is the conversational data. So the Q&A, for example, answer. For example, MMLU. So this is from SmolLM2 training, so which is 1.7B, I think. Yeah, I know. I don't think.
Very small.
And yeah, very small. And this is basically until like 6.5 trillion of tokens, so which is a lot, to be honest. Until this amount of token, the MMLU in the QA formats, so meaning that the model have to select which answer is, the model have to output, for example, the right answer is A or B or C or D. And this is random. like for 6 trillion tokens, it's random. So this is a big deal. And it only learn after like 6 trillion token to basically answer question in a QA format. And this is because we didn't do at the time a lot of, we didn't include a lot of Q&A data in our training set. And this is also from a blog post from Datology. And you see that their training sets, like their data set is very good at MMLU. And this is like mainly because of the format. Like all other data sets are random because they don't have like QA formats. And they don't disclose it, I think, but maybe they do, to be honest. But this, like the fact that they gain accuracy on MMLU and it's not random is because there is some Q&A formats inside the dataset. So you see, like, if you just look at the benchmark, you could say, for example, like DCLM is very bad or it's very bad quality data, or I don't know. But with a very light rephrasing and let's say a style rephrasing, so you take the document from whatever dataset and you put it in QA format, you would have like non-random performance on MMLU. But yeah, this is pretty.
You're very, very sure it's not training for tests, right? Like,
yeah,
this is obviously the problem.
Yeah, there is obviously some contamination, but I mean, 40% is not that much, to be honest. I mean, it's great, but it's not like 100% or something like that. So I'm not sure it's contamination. It's more like Q&A formats, and that's what they also find here, is that you basically have better performance where you put some conversational data into the training, and this basically plateau at 20%. Which is good to know. So,
yeah. Okay. And, one of the reasons I think we've been following the Rephrasing the Web research for a while. I think one of the reasons that like I was a little bit anxious about this is that now the data set is too clean. It's too perfect, right? I paste in a lot of shit in my data set, in my prompts, right? So can it recognize my typos? Because if it's never seen a typo in its life, it's not going to be understanding typos, right? Typos are just one simple form of mistake. There's grammatical mistakes, but then there's also mild conceptual mistakes, all of which gets cleaned up with rephrasing, and sometimes that's bad.
Yeah, I totally agree with you, and especially since like all the benchmark we have, we don't have like typos benchmark. I think there is no such things. I mean, they probably is to be honest, but I don't like people don't usually benchmark against that. Obviously, like the dataset innovation and the model innovation, like always are biased towards like maximizing performance on some specific set of benchmark. And you kind of miss those use cases, as you said, which is our real case, real like user, like the thing that user care about, to be honest. And, but I'm not that worried because I think the solution is just to include some bad data as well. And the model is just learn, on it. And you can probably include, there is probably some scientific ablation to make on that. But you train on so much trillion of token data that, to be honest, I think the model have time to learn that sometimes users are typing bad stuff into their prompts.
Yeah, I still see. I feel like there will be some trade-off somewhere because, like, obviously you have much fewer typos. I'm not just talking about typos, right? I'm talking about like I'll copy and paste like website data and I just throw shit in there. Like because the pre-training data is bad, I actually have confidence that you can handle bad data because I'm going to paste in bad data. Anyway, so separately, I also wanted to mention, do you cover the Tencent trillion persona paper? Because like persona rephrasing, billion persona, trillion persona. Basically, persona rephrasing is a very interesting way of doing multiple epochs, and you never repeat yourself, but it's actually kind of the same content. It's just you're rephrasing. So
I think that's kind of what they did in Kini K2 ablation. Yeah. I'm not sure. I didn't read the paper. I will read probably after
this. It's basically role play, right? Like you're a doctor, blah, blah, blah. You're a physician, blah, blah. And then like it's slightly different.
Yeah, I totally agree with you. I think that's pretty important. And there is this paper from actually from people at HuggingFace at the time that is saying that you basically can repeat your data like up to 3 epoch before seeing diminishing gain, before seeing diminishing return.
4 is what I remember, but yeah.
I don't remember exactly the number, but I don't think they do ablation on like the different datasets. So with Lumna, which is Lumna Benal at HuggingFace.
She spoke at my conference last year. Yeah.
Yeah, I was there, by the way.
Oh yeah, nice.
Was in the public.
We're going to do that again at NeurIPS.
Oh, so at NeurIPS?
Yeah. Are you coming, San Diego?
Probably yes. I'm not sure. I didn't book my flight, but I think it will become. And I think this is like heavily dependent on the dataset, and this is very underexplored. For example, we have like the FineMath dataset, which is very high quality math dataset. We also have like the StackEdu one. And I'm pretty sure that if we repeat more time the FineMath dataset, this number of 3x, we can probably repeat more of high quality dataset because it contains like more information. And what you say is like with rephrasing, you can pretty much get probably something, I don't know, I didn't do ablation, but you can probably do like this 10x factor when you can repeat your data by rephrasing it a bit, a lot. Like you can repeat it quite a lot. And I think this is quite underexplored, and I would love to see some papers, or maybe I would do it myself. I don't know. But yeah, this is pretty cool. And this is kind of good old data augmentation that people were doing like during the time of computer vision, with basically, I don't know what they were doing, but they are like shifting the image, zooming out, zooming in, adding some bit of noise, stuff like that. And they had better generalization, meaning that the train and test loss were a bit better. So yeah, I think this is still an open question, at least in the open, at least from my knowledge. And this is pretty important one.
I think the last dataset piece question I have, and I'm happy to change topics, is one of the lessons that we had from the datology episode was that effectively what we're doing was we're moving the post-training data into the pre-trained data, right?
Yeah.
You talked about this conversational rephrasing. That's instruction tuning.
Yeah. I mean, there is all this mid-training stuff that's, I mean, you can inject the data during post-training, mid-training, pre-training, whatever. I think what matters is that what matters is like the model see your data, and post-training should be to basically sharpen the distribution of your model to very specific topic. And so for me, it's good. And that's what people do nowadays, like GNM. I think they train on, I don't remember exactly, but I think it's like 8 trillion token at the mid-training stage. Can you call it mid-training? I'm not sure, to be honest.
Call it whatever you want.
It's pretty crazy. Yeah, 8 trillion token is like, and they train only on code and math, and they do some rephrasing as well. And yeah, I think that's basically what a lot of people are doing now. And we are doing this as well. We are basically introducing higher quality data. Like, I don't know where it is, but if you look at our different phase, we are basically adding more code and math through the training and less web data.
Yeah.
But we're only doing it like 1.1 trillion token, which is maybe.
Yeah, but by the way, this chart, we haven't pulled it up yet, but like this chart, was what wowed me on the SmolLM 3. I was like, this might be the most open paper I've ever seen.
That's what we try, at least, to be as open as possible. We also release like all the checkpoints, the intermediate checkpoint we have. I mean, we didn't release it all, but every 10 billion token, I think, or no, I think 50 billion. I don't remember exactly what I pushed to the hub, but every like 50 billion token, I think there is some checkpoints. And yesterday I was talking about some stuff about pre-training, and someone was saying, I hope like it would be cool if you release the intermediate checkpoint, because I need to do some analysis about the pre-training dynamics into SmolLM 3. I mean, it's here, you can use it. But this is pretty cool, and I think that's what we try to do. We also open source all the code base, so There is the Nanotron, which is doing the large scale training. There is the Datatrove, which is doing the data filtering. I think this one is very underrated. And it's very good. That's what we use to do FineWeb and FinePDF. Yeah.
Should we talk about that? Let's open it up. I've never seen this, never heard of it.
Yeah. Datatron? I mean, it's just a library that do data filtering and tokenization at scale. So you basically, it's very efficient to do this we do it on CPU mainly. And there is also I think we are doing some pipeline for doing rephrasing also inside the Datatrove library. We also have the light eval one to do evaluation. And we have a lot of stuff there.
Yeah, light eval. I mean, I think a lot of people are like trying to move from the HuggingFace harness and
the LM eval harness.
Yeah. Is light eval the new standard now? Should everyone be running that? Like,
I think it's pretty good. The Datalogy, the Beyond web paper, they use light eval.
Yeah. I think the community should have one. It's just that everyone is like, even the OpenAI evals framework was so heavy that they had to release like, okay, hey, our main framework is too heavy. Here's the simple evals, and then they don't even use that. So I'm like, I don't know what to use, man.
There is the eval framework every day.
Yeah,
I think there is a lot of stuff, but I'd like to think that this light eval one is great. And I think one thing which is cool at working at HuggingFace is that we have this multimodal team which is doing like the SmolLM. You have the robotic team. To be honest, I'm not really involved in that, but they are doing the SmolLM model, small VLA, sorry, which is like the vision language action stuff.
Yeah.
But this is pretty cool to have like all those people working with we are like our SmolLM model as a backbone and then building some stuff around it, even inside our team at HuggingFace. So this is pretty cool. Yeah.
So many memes.
Yeah, I mean, I didn't make all the meme yet, but I have so much. Like this one was like, so this was for SmolLM 3 and I was doing ablation on Optimizer. And basically I was like, I mean, when I fell asleep, it was like here. So there was like no spike at all. And I woke up and my graph looked like this. And I was like literally crying because all my training was diverging.
This is the quantum observer effect on training runs. When you're watching it, nothing happens.
Yeah. And when you fell asleep, like you woke up the day after and it's a nightmare. But we solved the bug. I think it was a bug in our code base. And this was the main reason for all the spike. And there is some fun stuff. Like for instance, when I was doing ablation on Muon, I was looking at like the Qwen norm, and the Qwen norm was doing this like M shape, and I was going a bit crazy because like this is like the M of Muon. I was saying to people, so it's always funny like on the Slack that people are. I think that's like one of the great thing at HuggingFace is that people are like having fun by doing all those ablation. Yeah.
All right. I know we're getting to time and you got to go back to updating this with all the news from the last 1 hour that you've been here just to make sure it's up to date. Any parting thoughts on SmolLM, especially? I think there's, obviously, even when GPT-OSS came out, a lot of excitement about open models, local models, blah, blah, blah. And then I think, maybe the reality is that there's not as much adoption as people would like. Is there anything you wish people would do more of? Maybe like underrated use cases for which you think these smaller models are like just as good as the frontier ones that people are not taking advantage of?
Yeah, I think even I, to be honest, I'm mainly using closed model because it's easier, basically. It's like the same interface when I'm like, for example, researching very deep on papers. And when I'm, for example, doing like translation stuff, I want to translate something from English to French. But I know some of the heavier users are using the SmolLM 3, for example, for translation. There is also obviously all the on-device application, which are super important. There was this Apple keynote 2 hours ago where they have said the word AI 1,000 times probably. And yeah, so obviously on-device applications are super important. And for the future of SmolLM, I think our goal is basically to build the model that the community don't have and need. So we are super open to feedback. Don't hesitate to tag me on X or HuggingFace or whatever. If you have like if you think that there is like some gap in the like what all the open source model are today, and you wish there was more, for example, very small model like under 1 billion parameters or thing like that. Yeah, I think we are pretty open on what to do next. We want to train our MOE because it's fun and everyone is doing that. And also I think there is a lot of different direction, and it's always good in terms of science because basically the Qwen 3 or even DeepSeek, they don't release all the ablation they do. And I know as a researcher that that's something super important. And so when we do model training, we try to be as open as possible. And obviously, it's often appreciated by the community. And yeah, and so that's one thing we want to explore with this MOE. And we also have a project to do some distributed training across like different data center, like Prime Intellect did, for example. And yeah, this is a project I'm looking forward as well.
Awesome. Yeah, I do hope that there will be an easier way to just use these SmolLM models through API.
Yeah.
I found that a little clunky right now, just to find something that is token based, because the HuggingFace API charges by the hour, which kind of when you run it ends up costing the same as some of the other models. Like I have this like a MCP client I built, and we use Llama 8B for like a conversation naming. I feel like that's like a great use case for like a 500 million parameter model, but there's no simple API to use it. I feel like that's another, in a way, it's almost like it's not economical to serve these models because they're so small. And so I think that's where they get stuck. It's like who's really serving the 500 million to a billion parameter models? I think that's what hopefully HuggingFace can do more there too.
Yeah, that's very true. I think we should do some stuff. Yeah.
But thanks so much for the time and the masterclass. I don't know, is this file online anywhere? I think this might be the most valuable.
Yeah, I mean, it's not online yet, but I will probably share maybe a more polished version of it. This is literally my draft, so.
This is probably like the most valuable TL draw file ever. Like I think this file, this canvas is probably worth millions of dollars of insights from your talk. So excited to see the final product, and we'll link it.
Yeah.
We'll make sure to release this maybe once the talk is also out, so that then people can see the full slides.
Just a parting question, because I see that you care a lot about training, optimizing, and all that, and multi data center, and probably like multiple architecture. Like if you got some AMD, you want to use that. Have you looked at modular at all? Like, is that interesting to you? Why?
So your podcast with the.
I'm just wondering, like what's the state of that? If you took a serious look at it, if you haven't, then I'm just checking.
You mean like modular the language? Or the just training on different architecture?
Language and runtime, right? Basically, like they're basically offering like a superset of Python that should be good for you, you specifically. You are the target audience for this. And if and I'm just kind of trying to hear about like feedback or like.
Yeah, I'm not very knowledgeable about it, but like the pre-training code base is something that you basically build through training, and you iterate on it. So like changing some like heavy stuff in it are always like a big deal for a researcher, I think. Especially that everyone is like their own preference and stuff like that. So yeah. But I'm not really knowledgeable about all of that, and I need to watch your podcast with them. It's actually on my watch list. Look, so yeah.
I see Rust in your code base, I see Python, I see, you're experimenting with different optimizers. Like, I'm not like the perfect ICP for them, but like you are. And so I'd be curious to hear like someone who doesn't work for them. Like what's your opinion, Cool.
And I never tried, but
it's hard to try things. Yeah. You have a thing that works. Like it's, yeah. Cool. Well, thanks so much for your time.
Yeah, thanks a lot for the invitation, and see you in Paris.
See you in Paris.
You sure? Yeah.
Awesome.